We will add interactions to our previously chosen selections. On the data tab, we are going to keep all our previous selections, the data set being R2 data set and our dependent variable being systolic. Our categorical exposure variables or the independent variables being sex and cholesterol, and our continuous exposure variable being BMI. On the model tab, again click on edit button. We have all these three variables already selected. Let's remove them back. Let's remove them and then we will add them again. Okay. So now select all of them. Instead of adding, we have the options of either including full factorial or n-way factorial. If we add full factorial, what will happen is that it will provide all the possible combinations between the three of our exposure variables: BMI, sex, and cholesterol, BMI and sex, BMI and cholesterol status, sex and cholesterol status, and BMI into sex into cholesterol status. So the last one is the combined influence of all these variables on systolic blood pressure, which is mostly not required. Only two-way influence of these variables are enough to find any additional influence of these variables on our outcome. So I'm going to just remove it from our model. The easier way to include them in this way is just use this button, n-way factorial. Let me show you how we can do that. Okay, I'm going to remove them. I have selected all my variables. I will click on n-way factorial, and then I have the option of having them two-way, three-way, or four-way, whatever number of ways we want them. We want these interactions to be analyzed. But I'm going to keep n is equal to 2. That is only two ways. So in this way, now we do not have that three-way influence of these variables on our outcome of interest, systolic blood pressure. Okay, so I'm gonna hit OK, and on the options tab, I'm just gonna change one thing which we always do, and I will submit the code. Okay, here are our results. Control A, Control C, Control V on ChatGPT, and submit all the results. Okay, perfect. Thanks for pasting the full model again. Let me give you a clear structured interpretation of these. Okay, so model fit, R square is 16. So we see that the R square has gone slightly above. Now 16% of the variation is explained by these three variables and their interaction. Not a huge jump, but still there is slight increase. Okay, the adjusted R square is very close to the original R square, which is kind of reassuring. Okay, the overall model fit is statistically significant. Okay, the main effect, BMI effect on systolic blood pressure has gone slightly further down, so almost 1.9 millimeters of mercury systolic blood pressure increase with each unit increase in BMI. And among male and female, now we see that females tend to have almost 6.5 millimeters of mercury systolic blood pressure lower than males. So now that superiority of the female gender when it comes to the cardiovascular health is in question. That superiority has kind of been reinstated. Okay, so as far as the cholesterol status is concerned, when compared to the high, the people with high cholesterol level, those with borderline cholesterol, they now have a slightly higher systolic blood pressure, and even the desirable, the people with desirable cholesterol status have slightly higher. So that's a kind of a unexpected results, right? But we see that the p-value is not significant. It is 0.5. So probably now with the interaction, it means that the cholesterol probably had effect on systolic blood pressure through more complex way that we will see among the interactions. Okay, so here is the BMI and gender's combined effect on systolic blood pressure. We see that females have with the when we factor in the BMI, the females have in fact higher impact. So let me take a few steps back and just use the words which ChatGPT has used. BMI impacts women's systolic blood pressure more strongly than men. That's the best interpretation. I couldn't really say in these words. Okay. So here is the interaction of BMI and cholesterol. That is the combined effect of BMI and cholesterol on systolic blood pressure. I'm just not gonna even try using my own interpretation and just stick to one which is provided by ChatGPT. The systolic blood pressure effect on BMI is weaker among those with desirable cholesterol. Oh, that's awesome. Okay, and borderline and BMI has almost no effect or very little, like 0.2 millimeters of mercury. Moving on, gender and cholesterol, we see that women with desirable cholesterol have 9 millimeters of mercury lower systolic blood pressure compared to men in the same category. Okay, so it appears that the effect of cholesterol is through the sex when it comes to the systolic blood pressure. Women benefit more from good cholesterol than men. That's an important finding. Okay, so I'm gonna kind of skip the rest of the interpretations and we'll jump directly to the key takeaways. BMI is a strong driver of high blood pressure, particularly in women. Cholesterol moderates BMI effect. With desirable cholesterol, the BMI's systolic blood pressure relationship weakens, and so on. So here's the clinical message: improving cholesterol status may offset some of the BMI related risk, especially in women.